Okay, in this video we are going to be looking at parallel and perpendicular lines today and coming up with equations for some of them and looking at some properties of them. So parallel lines, as you know, are lines that never cross, just like the picture on the left, the two blue lines. What they have in common is their slope. So parallel lines have the same slope. You can see that this one would go up 3 and right 1, and this one also goes up 3 and right 1. So they have the same slope. So parallel lines have the same slope. Okay. Perpendicular lines, though, their slopes are a little bit different. If we look at the red line, this one goes down 1 and right 2. So it has a slope of -1/2. Whereas the blue one goes up 2 and right 1, so it has a slope of +2/1. I want you to notice that these two fractions right here are reciprocals of each other, and the sign has changed. This one is a negative, and this one is a positive. So that's how perpendicular lines look, and I know it might be a little bit distorted here on the smartboard, but this is a 90-degree angle right here. And so perpendicular lines have opposite, which means the sign changes. If one's positive, the other one's negative. Reciprocal slopes. Okay? So with that in mind, we're going to do a couple of problems. In this problem, what I'm giving you is I'm giving you one line, and I'm giving you a point, and I want you to find an equation for a line that is parallel to the one that I gave you and a line that's perpendicular to the one that I gave you that passes through the given point. So what I've done here is I have given you an equation for y equals 2x minus 4, okay, and I've graphed that line on this graph just so that you can see it. And then I want you to draw a line that's parallel to that one that goes through the point -1, 2. So I'm needing to find an equation for that line right there. And then perpendicular to the blue line, but that goes through that same point. So I want you to find an equation for that line. That's kind of what we're doing, okay? Again, what you know is that parallel and perpendicular lines are related by their slopes, okay? So the reason I gave you this equation right here, the only reason I gave you that equation right there, is to be able to find the slope from it, because parallel lines will have the same slope and perpendicular lines will have opposite reciprocal slopes. Notice that none of these three lines, neither the blue, the red, or the green, have the same y-intercept. And so the y-intercept of this equation means nothing. It is null and void. You don't ever use it, just so you know. Okay, they all cross the y-axis at different spots. So, excuse me. Again, I'm giving you this to identify its slope. So what I know about that blue line, the one that I gave you, is that the slope is 2. So if the blue line has a slope of 2 and parallel lines have the same slope, then I know that this one must have a slope of 2. And then if perpendicular lines have opposite reciprocal slopes, I know that if the blue line has a slope of 2, this one has to have a slope of -1/2 because I have to switch the sign and do the reciprocal. Okay, then what I know is that in both instances, it has got to go, the line I'm trying to find has to go through the point -1, 2. Okay, so what you're going to do is you are going to use the equation of the point slope form, y minus y1 equals m times x minus x1, and you'll just plug that information that you have in. So here's my y1 right here, which is 2. My slope I know is 2. And then x minus x1, which is right here. So minus a -1 becomes +1. So here is that equation, just so you know, in point slope form. So we can leave it right there. And then I can distribute that 2 through so that I can get this into all three forms too. So if I distribute the 2 through the parentheses, I will have 2x, and then 2 times 1 is 2. And then I will add the 2 over. And I will have y equals 2x plus 4. There's my equation in slope-intercept form. And then I'm going to go ahead and get it in standard form also. And so to get it into standard form, I would want the x's and the y's both on the left side. So I'll subtract this 2x over so that I have negative 2x plus y equals 4. And then remember the rules of standard form tell you that your leading coefficient can't be negative. So that number right there can't be negative, which it is right now. And so I'm going to multiply every single thing by -1. So when I do that, I'm going to distribute that -1 through, and this will become positive 2x and negative y and negative 4. Don't forget to distribute the negative to the right side. That's a super common mistake. This right here would be standard form. Okay, so those are parallel. And now we're going to kind of repeat the same process over here with perpendicular lines, okay? So same thing, you're going to still plug things into y minus y1 equals m times x minus x1. Notice your y1 and your x1 are still the same. It's -1 and 2. The only thing that's different is your slope. Your slope now for this one is -1/2, okay? So I will have y minus 2 equals my slope, which is -1/2, times x minus -1, which becomes +1. Again, this is in point slope form. Okay, I'm going to distribute that -1/2 through to have -1/2 x and then -1/2. Add the 2 over. -1/2. 1/2 plus 2 is 1 1/2, which is 3/2. So here it is in slope-intercept form. And then in standard form, we can't have fractions there. So I'm going to go ahead and multiply this whole equation by 2. So obviously 2 times y is 2y. And then 2 times -1/2 x is -1x. And 2 times 3/2 is 3. And then I'll go ahead and add the x over to the other side so that I have x plus 2y equals 3. And there it is in standard form. Okay? If you peek at these equations in slope-intercept form, this red one has a slope-intercept form of 2x plus 4, and I just estimated this. So I just drew it kind of sloppily, but I'm pretty close here on this red line. And then the green line should have an equation of y equals 1/2 x plus 3 1/2. And my green line matches pretty closely with what my equation should look like. All right. The only difference on this next one is that when I gave you the equation from the beginning, I don't have it in the right, it's in standard form right now, and standard form doesn't do me a whole lot of good. Again, the reason I'm giving you this equation right here is to be able to find its slope from it. That's the only reason you're going to use it, okay? So in order to find its slope, I either need to have it in slope-intercept form, or I need to have it in point slope form. Standard form isn't going to give me my slope, and that's what it's in right now. So I'm going to go ahead and get it into slope-intercept form, which is y equals mx plus b. And so I want that equation basically solved for y. So I am going to subtract the x so that I get 3y equals -x plus 6. And then I'll go ahead and divide by 3 all the way across so that I get y equals, there's this imaginary 1 right there. So I have -1/3 x plus, and then 6 divided by 3 is 2. Again, the absolute only reason you use that equation is to find the slope from it. The slope is right here, which is -1/3. Okay, I've graphed that blue line over here on the graph so that you can kind of see that. That's what it looks like. And I'm first of all going to find an equation of a line that's parallel to that blue one, but that goes through the point 2, 3. So I've graphed the point 2, 3 for you. I need to find basically the equation of that line right there. Okay, again, parallel lines have a slope that are the same. So the slope of this one is -1/3. Okay, and the slope of this one, which would be perpendicular to it, okay, perpendicular slope would have the opposite reciprocal, so that would be a +3. Okay, from here on out, it is the exact same as the last problem. You're going to use the point 2, 3 again that I gave you. So I gave you the point 2, 3, and you're going to use that point in both cases. Okay, and so I'm just going to get this one started. I probably won't do the whole entire problem, but I'm going to get it started for you. And so again, I will start by doing y minus y1 equals m times x minus x1. Okay, and I'll go ahead and plug my information in. So in this case, I will have y minus y1, which is right here as 3, equals my slope, which is -1/3, times x minus x1 right here, which is 2. Okay, there it is in point slope form. I am not going to take the time on this video to show you all of them, but if you want to do them and check your answers, I will tell you what they are. So in point slope, it's that. In slope intercept form, it would be this. And in standard form, it would be this. So all of those equations are for the line that is parallel to the one I gave you and goes through the point 2, 3. Okay, perpendicular would start out like this. Y minus y1, which is 3, equals m, which is 3, times x minus x1, which is 2. Okay, so there's that one in point slope. And then if you want to simplify these and hit pause and go ahead and check them, I will give you the answers in the other form. I just think we've done it enough that you don't need to watch a video about it. Okay, so there they are in slope-intercept form and in standard form. All right, and then we're going to look at a special case here where I give you an equation that is sort of different, okay? The equation on the line is y minus 5 equals 0. Notice it does not have any x's in it, no x's, which tells you it's a special kind of a line. I'm going to add this 5 over, and I have y equals 5, okay? Again, it only has a y value in it, and when it has a y value in it, it's going to be a horizontal line. Because my y values are being held constant at 5, my x values are not there. So if you look at that line again here, x is 1, but y is 5. Here, x is 5 and y is 5. Here, x is -2 and y is still 5. So no matter what my x values are, my y's are being held constant at 5, which means it's a horizontal line. Okay? If a line is going to be parallel to a horizontal line, it also has to be horizontal. Okay? So parallel to that through the point -3, 2 would look like this, okay? It's still a horizontal line, and horizontal lines always have the equation y equals something. So in this coordinate that I gave you right here, your y value is 2. So parallel to that would be y equals 2. Perpendicular to that blue given line that goes through the point -3, 2 would look like this. I should have drawn that in green, sorry. Let's draw it in green. Okay, that is the perpendicular line. And perpendicular lines, perpendicular to a horizontal would be a vertical line. And vertical lines always have equation x equals because it's the x that's being held constant. And at this point right here, your x value is -3. So perpendicular to that would be x equals -3. Okay, so be careful. I might give you a vertical line to start with, and then parallel would be a vertical line, and perpendicular would be a horizontal. So, but those are special cases, and that's how that works. Okay, so So we'll see you next time.